Hi everyone. Today we're going to take a look at a few questions off of this integration review group work worksheet. So let's start off with problem 1. So problem 1 is a question that we've talked a little bit about in the past. F of x here is a piecewise function. So negative x squared when x is less than or equal to negative 1, 2x plus 1 when x is greater than negative 1, and we're trying to find the value of this integral from negative 2 to 3 of f of x dx. So basically, with this piecewise function, we're just going to break it up into two integrals, right? And so if we look at where the piecewise function breaks off at negative 1, right, that's in the middle, not in the middle, but it's in between our lower and upper limit of integration, right? And so we can go ahead and break it up there. So if I take the integral from negative 2 to negative 1, right, that's going to be the negative x squared dx, right? That'll be negative x squared part of f of x. And if I take the integral from negative 1 to positive 3, that'll be the second part. That'll be the 2x plus 1 quantity dx. Okay, so when you have a piecewise function and you're integrating, you just got to go ahead and break it up. Okay, so luckily this one is nice. Two simple antiderivatives, negative x squared. Antiderivative is negative 1/3 x cubed, right? This is going to be from negative 2 to negative 1 plus quantity 2x plus 1. So that's going to be x squared plus x from negative 1 to 3. Okay, and so let's go ahead and plug in all of our numbers and see what this simplifies to. So this is going to be negative 1/3 and then negative 1 to the third minus negative 1/3 and then negative 2 cubed. Okay, so that's our first part right there. And then the second part plus, this is going to be, let's see, 3 squared plus 3 minus quantity negative 1 squared plus a negative 1. I'm just going to write minus 1. Okay, so let's go ahead and evaluate all of this. So let's see, if I plug in negative 1 cubed times another negative, that'll be positive 1/3. And then let's see, I have a negative on the outside of the parentheses and a negative on the inside. I have negative 2 to the third. That's 5 total negatives, so this one's actually going to be minus, right? And then 2 to the third is 8 divided by 3, so that's minus 8/3. 3 squared is 9 plus 3, so that's 12. And then negative 1 squared is 1 plus a negative 1, so that's 0. Okay, so those cancel each other out. So, oops, sorry. So this is all I have. Okay, and so this is going to be negative 7/3 plus 12. 12 is the same thing as 36 over 3. Right, and so combine these, we get 29 over 3. And so we get an answer of C. You can go ahead and write that there. Okay, so that one's not too bad. Okay, when we've got the piecewise, right, we just have to go ahead and break it up, right, based on the domain of our piecewise function, right? So an integral up till negative 1 and then an integral starting at negative 1. And then we pick the appropriate function based on the domain we're told. Okay, so let's now jump down to problem 5, because this one is a little bit tricky. Which expression is equivalent to the integral from 2 to 5 of f of quantity 4x plus 2 dx? Okay, now the way we say it, right, should be a hint there, right? This is f of 4x plus 2. So when we do U-sub, right, just like when we were talking about chain rule in the past, right, we want to look for compositions of functions, right? F of g of x, right? So when I say f of 4x plus 2, that's my inner function, okay, right? 4x plus 2 is on the inside, all right? So that's what I'm going to let u equal, 4x plus 2. Okay, and now if I take the derivative of that, the derivative of 4x plus 2 is just 4, and I'll write dx with that. But I don't have a 4 dx, I have just a dx, and so I'll divide that 4 over, so I get 1/4 du is equal to dx. So let me just highlight my u for my substitution, and now my substitution for the dx. Okay, and so f is some function, right? I don't know what function f is, but I know this is a composition, which is how I know to use U-substitution. Okay, so I let the inner part be my u, right? Take the derivative, isolate the dx, because in this case, there's nothing else in my integral, right? You know, there's nothing else here. Whoops, I'm sorry. There's nothing else here, right, for me to try to, you know, sub out when I do my U-substitution, okay? And then the last thing I'll do is worry about my limits of integration as well, 2 and 5. Those are values of x. I need them to be values of u, right? And so u is equal to 4 times 5 plus 2. U is equal to 4 times 2 plus 2. The limits of integration are actually a really nice place to start, okay, right? Because it's a nice way to eliminate options when you're doing a multiple choice question, right? So even if I'm not sure on the U-substitution part, it's very unlikely that the limits of integration don't change from when you convert them from values of x into your values of u. So 22 and 10, right? So automatically I know C is wrong, D is wrong, right? None of those have limits of integration 22 and 10. So I got to have it down to A and B. So let's do all my substituting and let's see what I get. So again, this is going to be the integral from 10 to 22. So substitute in values of u, okay, right? F is the outer function in this composition. Again, I don't know what f of x is, right? It could be natural log. It could be sine of something. It could be sine inverse of something. Who cares, right? We don't know what it is, so we just use the notation f of, and now, right, what was inside now says, we'll just go ahead and leave that there for a moment, and you can enjoy what that says. Okay, and then the last part of the integral, the dx, I'm going to substitute out with a 1/4 du, so times 1/4 du. So there's my u substitution, all done. Okay, and then the only last thing I have to do, right, is take this 1/4 and we'll move that out. Okay, we'll move the highlighting orange box back to here, and I'll highlight this in orange as well, just so we know where it came from. And so that tells me that my answer is A. Okay, we're going to do a couple in a row here. So let's take a look now at number 6. So this one is actually pretty straightforward, right? It just gets a little bit tricky, right? We have to remember quite a few different rules here, some trig stuff, okay? Problem 6, perfect type of AP question here, right? They're telling us what u should be, right? They're giving us the integral 0 to pi over 2 sine of 2x times e to the cosine of 2x dx. And again, the question says u should be cosine of 2x. So that is what I'm going to start with. Okay. And so I'm just going to go ahead and write over here that u is cosine of 2x. And now when I take the derivative of that, so now we have to remember some trig derivatives. Derivative of cosine is negative sine of 2x, but because it's of 2x, I have to remember chain rule. So I have to multiply by 2, right? And then I have to put dx here. Okay, so again, the question tells me what my u was, right? But taking the derivative of this, right, is a totally different skill, right? This is, do a derivative. We have to remember, how do we do the chain rule correctly? Do we remember this trig derivative correctly? That is all vital, okay? And now we can look back at the integral and go, well, what's in my integral, right? My integral has a sine of 2x. That's great. It has a dx, right? And so this other 2 here, right, I'm just going to go ahead and move that over. Oh, and actually, I also need to move the negative because that's also not in my integral here, okay? So I'm going to divide the negative and the 2 over to join the du. So I'm going to write negative 1/2 du is sine of 2x dx, right? Sine of 2x dx is what is in my integral, okay? Right, the e, right, that part stays. So negative 1/2 du is equal to all of that, okay? Pardon me. Okay, so limits of integration, 0 and pi over 2. Let's go ahead and convert those to values of u instead of values of x. So u is equal to cosine of 2 times pi over 2. So 2 times pi over 2, that's cosine of pi. That's negative 1, if we remember our unit circle correctly, right? Pi is 180 degrees. Cosine is negative 1 there. And then u equals cosine of 2 times 0. So cosine of 0 is positive 1. Now, this is a place where people make a lot of mistakes, okay? The upper limit of integration here was pi over 2. When I plug that in for u, right, I got the smaller limit of integration of negative 1, okay? But that's all right, all right? It's okay that that happened, right? But we just have to make sure we're consistent. Negative 1 has to go in the top of my integral, okay? Plugging in 0, my lower limit of integration got me positive 1. That has to go on bottom, okay? Now, one thing I'm going to notice right away when I look at all my options, well, first of all, there's a couple that don't have negative 1 and 1 at all. So B is out, E is out, okay? And when I look at the rest of these options, right, integral negative 1 to 1, integral negative 1 to 1, integral negative 1 to 1, right? So all of those are in actually the reverse order. So we'll talk about how to deal with that in a moment. Okay, let's go ahead and do my U-substitution so I can rewrite all of this as the integral. Again, keep it in the order in which you evaluated it. Pi over 2 got me negative 1. That has to go on top. Plugging in 0 got me positive 1. That has to go on bottom. Now let's do the U-substitution for my integrand, right? So this is going to be e to the u du. Oh, I'm sorry, not du, you dummy. I'm calling myself the dummy there. Negative 1/2 du, duh, that's what I was substituting, right? So again, the sine of 2x dx became negative 1/2 du, and the cosine of 2x, we were told to make that u, right? And then again, the 1 on bottom and the negative 1, right? That has to be done in that order. And so, if I look at all my options, none of them have negative 1 and 1 in the order that I do. All of them have it flipped, right? And so this tells me that my last step is to use this negative to flip these limits of integration. So this integral is the same as, let's take the 1/2 out, right? I can multiply by a negative 1. This negative can be used to flip these limits of integration. So I'm not going to write a negative here. This can now be negative 1 to positive 1 of e to the u du. And that can be my final answer, right? Positive 1/2, right? And so my correct answer is D. Okay. So again, that one is very tricky, right? And that's why there's a little warning here. You have to be very, very careful, okay? There's a couple of places you can make a mistake with this one very easily. The first one, and the one that scares me the most, derivative of cosine is negative sign. If you forget that negative, right, it could mess up all of your work. The other mistake, right? If you put these in the wrong order, when you do your U substitution, if you just assume, yes, the bigger number must go on top, right? You're going to pick option A because that one has a -1/2, just like our work did. Okay, so you have to be very careful with that. Okay, let's take a look at one more. This one is not too bad. Okay, let's take a look at problem 7. So this one, we're just going to evaluate. All right, so let's go through this. Okay, integral -2 to -1 of 4t over 2 minus 8t squared dt. Okay, so don't really see anything else I can do here. Remember, you cannot simplify these fractions. You can't do 4t divided by 2 and 4t over -8t squared, right? You cannot do that, okay? So instead, let's go ahead and do some u sub, right? I see an exponent here, right? T squared. Its derivative is t to the first. So let's let u be 2 minus 8t squared. Its derivative, du, is going to be -16t dt. Okay. So let's start with the u, right? So, we talked about this in the past, right? When you're trying to pick a u, right, you can put your denominator in parentheses in the fraction. That's very often going to be the case when you're doing u sub, but not every time, right? But this time we do want the whole thing here to be the u. Okay, and so take a look at what's left in the integral, 4t dt, right? All of that, right, needs to get substituted out to be in terms of u. So this -16t dt, right? What can I do with this? Well, let me go ahead and not divide the whole thing. I don't need to divide by -16, right? I can just go ahead and divide it by -4. So I'll get -1/4 du equals, and now -16 over -4 gives me positive 4t dt, right? And now I can match what is in my integral. So this is a little different than I think how I've shown you how to do some of these in the past, right? Very often when there's a coefficient here, I'll tell you to just take it out of the integral. Well, I'm cheating here a little bit, right? Because I know when I take the derivative of this 8t squared, it's going to give me something, right, that I can easily turn into that 4, right? So 16, I just have to divide it by 4, and I can turn it into this 4. Okay, so I didn't put it outside the integral. All right, so I left it there, and now I can go ahead and substitute all that with the -1/4 du. Okay, but before I do that, I do have bounds. Okay, so -1 and -2, let's go ahead and plug those in. So starting with my upper one, right, so 2 minus 8 times -1 squared, right? So that is going to go ahead and give us 2 minus 8, which is -6. And then u equals 2 minus 8 times -2 squared. So -2 squared is 4. Times -8 is -32. 2 minus 32 is going to be -30. So a couple of weird ones there. And again, this one is not just turn it into terms of u question. We have to do this fully using fundamental theorem of calculus, so we are going to evaluate it with these numbers. Okay, so pardon me, let's go ahead and do the substitution. Integral -30 to -6. This is going to be 1 over u. Excuse me. Times -1/4 du. Ooh, pardon me. Okay. And then I need to highlight my new limits of integration as well. Okay, so I can take the -1/4 out. 1 over u du in my integral is going to be natural log absolute value of u. Thank goodness we have this absolute value because we're going to be plugging in some negatives. Okay, and so this is going to be, and remember, when you have a coefficient here like the -1/4, I can just leave it out and do natural log, absolute value of -6 is +6, minus natural log, absolute value of -30 is +30. Okay. And now, hopefully we remember quotient property, right, for logs, right? Natural log of 6 minus natural log of 30. I can rewrite that. So this is -1/4, the natural log of 6 divided by 30, right? That's how I can combine these when I'm subtracting two logs with the same base. This can become natural log of 6/30, which is 1/5. And now, this is where it's nice on a multiple choice. Well, if this was free response, we could probably just stop right here because equivalent forms are fine. But when I look at all my options, they all have a +1/4 here as my coefficient. And so what that means is I'm going to go ahead and take the negative here. And we remember another property, right, which is that when I have a coefficient in a logarithm, right, I can go ahead and take it inside the logarithm and make it an exponent. So I can actually go ahead and rewrite this as the natural log of, and I'm going to kind of use a couple of brackets, parentheses here. Hopefully this will make sense, right? I'll keep the +1/4 out there, but that negative coefficient can come in and become a negative first power. And so I can go ahead and rewrite this as 1/4 the natural log of 5. Okay, and so that means B is our answer. Okay, so that's all we have for this time. Lots of good questions on this review. I encourage you to take a look at. Problem 8 is very good as well. Okay, problem 9, a little bit of long division practice is always good. And then number 10 is very similar to example 6, right, where you're given the u, right, another trig derivative. So always good things to review. Okay, all right, so that's it. All right, I will see you all next time.